Today I'm teaching you 10 advanced Python features that you need to know. They get more and more complicated throughout the video, so see if you can stick around and understand all 10. Now the first feature I'm going to go over is advanced unpacking methods. And just as an FYI, when I unpack the different features in this video for you, I'm aiming to give you a quick snapshot of the feature and encourage you to dive in deeper. So don't freak out if I don't cover everything, and remember there's some more details. I'm just trying to show you a ton of different features as quickly as I possibly can. Anyways, feature 1 is advanced unpacking. Now unpacking refers to splitting up an iterable object and grabbing its individual elements. Let's look at this example where we have a, b, c equal to 1, 2, 3. Now all this does is assign the value 1, 2, and 3 to the variables a, b, and c respectively, and this is a way to unpack something like a list. But this would work with a tuple or maybe something like a string as well if we wanted to do that, because those are iterable objects. Now if we continue down here, you can see that we can do something a bit more advanced where we use this asterisk operator. Now the asterisk operator allows us to collect multiple elements as a list, or we can actually use it in another way, which I'll show you later on, to kind of split up a list into its individual elements. So when I do a, b, asterisk c here, that means a will be 1, b will be 2, and c will be 3, 4, and 5. But what's interesting is that I can actually put the asterisks here, and then I get a similar result. I get a equal to 1, b will be 2, 3, and 4, and c will be 5. So let's execute this code to have a look at it here, and you can see that we have a1, b is the list of 2, 3, 4, and c is 5. So now we can change that and put that in kind of any order that we want, and Python will automatically give us the elements that we need. Okay, next we have ignoring values using the anonymous variable. Now the underscore is kind of a convention when you need to put a variable somewhere, but you don't actually want to access the variable later on. So rather than me writing in B and having an unused variable, I just put an underscore, which is known as the anonymous variable. And now what I'm able to do is assign a to 1, and then the underscore would be assigned to 2, but we don't actually use this, so we won't get any kind of error saying unused variable. And then we have c equal to 3. Now we could put this in any order that we want, and we could use it multiple times. So I could say underscore underscore comma c, and then c would simply be equal to 3. And you can see why we need to use that in this case in order to unpack this iterable if we just want to grab value c. Next, we can unpack nested structures. So for example, maybe we have a nested tuple, and we want to grab the name, age, and profession. Well, name, of course, will be the first element, but the second element is actually this entire tuple. So if I want to go inside of that and grab the other variables, so age and profession, I need to actually put a set of parentheses here when I do the unpacking. If I don't do that, I'll show you what happens. So if I just do it like this, which you might think would work, you can see that it says not enough values to unpack. Okay, now if we just do something like name and then we just put age here, thinking, okay, maybe I'll just grab the age. Same thing if I run this and then I try to grab variable age, it's actually the entire tuple. So what I need to do again instead is add that set of parentheses and then age and profession like that, although I believe I spelled profession incorrectly. Now the next thing we can do is unpacking in function arguments using this asterisk operator. Now similar to up here where we saw the asterisk, what it does when it's attached to a function argument or a function parameter, is it allows us to collect any number of positional arguments. So positional arguments are just ones that are placed in some order. So in this case we have Alice, Bob, and Charlie, and that aren't associated with something like a keyword equals blah, 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 okay? So here, in this case, I can accept any number. It could be 0, it could be 1, it could be 10. In this case, it's 3. And then it'll get stored as a tuple, and we're able to access all of those individual elements and print them out. So if I run this code here, you can see that we get Bob, Alice, and Charlie, or Alice, Bob, and Charlie in that order. Next, we're able to use the asterisk operator here to combine different elements inside of something like a list. So here you can see I have list 1 and list 2. Now, of course, I could concatenate these together, but if I don't want to do a list concatenation, I can use this syntax. The way that this works is it kind of unpacks this into its individual elements. So rather than having the entire list inside of here, like what would happen if I just wrote list 1 and list 2, it actually splits the elements similar to the spread operator in JavaScript, if you've ever seen that before. So that means that I kind of have like 1, 2, 3 being placed here, and then same thing, I would have 4, 5, 6, and you can use this asterisk operator in different cases. So sometimes you want to print out all of the elements inside of a list. So I'm just trying to get back to the original example here, and what you can do if you don't want to have the list kind of brackets showing up is you could say print and then list 1. Now what this would do here is just print out 1 space 2 space 3 because it's actually passing each of these individual elements as an element to the print function, where then they'll be separated by a space automatically. So let me just show you here. If I run this, you can see that I get 1, 2, 3, which is kind of what I'm illustrating, that we're passing each of these as an individual argument, and then that works the same way if we wanted to combine elements inside of this iterable. Anyways, let's quit that and go on to the next example. Now we can do a similar thing here with dictionaries. So with dictionaries, rather than 1 asterisk, you use 2, and same thing, it's going to kind of write the key value pair for you. So we'll write A, 1, and then B, 2, and you can use this in function calls as well to pass keyword arguments. Now, I'm not going to show an example of that because I have all kinds of videos on this channel demonstrating that, and you can kind of look at this more if you want. Next, we have swapping variables using unpacking. So I have x and y, and maybe I want to swap them. Now, typically, if I would want to swap these values, I would need to use a temporary variable that you might have seen before. But actually, what I can do is what's known as an inline swap using unpacking. So I can say x comma y is equal to y comma x, and now these values will swap without the need for a temporary variable. So let's go ahead and run this. And you can see that we get our before swap, x is 10, y is 20, and then after, x is 20 and y is 10. There you go. Let's move on to the next feature. So we're moving on to the next feature here, which is dynamic code execution. However, at this point, you've probably realized that if you want to understand this video, you first need to understand some basic Python. And in order to do that, you obviously can check out my channel, or you can utilize the sponsor of this video, Brilliant, which can help you massively. Brilliant is where you learn by doing, with thousands of interactive lessons in math, data analysis, programming, and AI. They use a first principles approach, meaning you'll get the why behind everything. Each lesson is interactive and filled with hands-on problem solving, which is 6 times more effective than just watching lectures. The content is created by award-winning teachers, researchers, and pros from places like MIT, Caltech, and Google. Brilliant focuses on improving your critical thinking skills through problem solving, not memorizing. While you're learning specific topics, you're also training your brain to think better. Learning a bit every day is super important, and Brilliant makes it easy. Their fun, bite-sized lessons fit into any schedule, helping you gain real knowledge in just minutes a day. It's a great alternative to mindless scrolling. Brilliant even has an entire suite of computer science plus Python courses that take you from complete beginner to expert, with hands-on lessons that cover the important concepts you need to master. To try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/techwithtim or click the link in the description. You'll also get 20% off an annual premium subscription. So moving on to dynamic code execution. Now this involves executing code that is dynamically written, or that we don't have kind of written in our Python script. Now there's 2 main functions we can use to do that. The first is exec and the second is eval. Now these are a little bit dangerous, so be careful using these, especially in any production code, because it allows people to execute code that you haven't already written, which might not necessarily be safe. So be very careful, especially if you're using this in some kind of backend, but I am going to show them to you because they are kind of cool and a more advanced feature. So let's say that we have some code snippet here that's written in something like a string. Maybe the user wants to execute some code and they're kind of writing in some input prompt and giving it to us. Well, we can actually execute that and have it interact with our own code. Now, the way we do that is with this exec function. Now, this exec function actually executes code within the current context of globals and locals. What that means is that if something like a local variable is defined or a function is defined, we can actually access it afterwards in our Python code. And same thing with globals, there's just 2 scopes, right? So the global scope is like the entire Python file, and the local scope is the scope in which we've executed this function, which in this case would be this function right here. Anyways, I know that's a little bit confusing, but the point is that exec allows us to execute some code and then access what's in the scope afterwards. It doesn't return any value or any result, as you can see here. It just kind of executes the code. So what I'm able to do is execute this Python function, or this code, which defines a Python function for me. And then in my local scope, which I have in a variable here, local scope, I can access the greet function. So I'm doing that from the local scope. And then I can call the greet function using Alice, or using really any argument that I want. So if I go down here, you can see that I have demonstrate exec. So let's just execute this. And sorry, that's not the way that I wanted to execute this. Let's just run the code. And you can see that it says hello Alice. So I can execute really any code that I want. And then later on, anything that was defined here, like a function, variable, class, I can access from the scope it was defined within. The reason why this is stored in the local scope is because when we execute code, we're inside of a function here. Since we're inside of the function, it means we're defining this function inside of this function, like it's a nested function. So local to the current scope, which is the scope of this function, is where this function belongs. If this was defined globally, then it would be in the global scope, which is this object right here. I know, a little bit confusing, but that's how it works. Okay, next let's go on to eval. So let me just call this demonstrate eval function and let's look at what it does. So for eval, what we can do is type in some kind of expression, which we can get directly from the user. And then we can just evaluate that and get the result. Now, eval is used for evaluating a single Python expression. So typically something that will give you some kind of result, although it's not always used in that case. So let me just show you what it looks like here, because I have eval expression. So I can run the code. I'm going to type some expression like print and, oops, we go hello world. Okay. And when I do that, you can see that it says hello world, and the result of the evaluation was none. Now, if I run this code again, maybe I do something like 1 times, or we don't want to do 1 probably. Let's do 3 times 9, and you can see that we get the result of the evaluation was 27. So the point is I can evaluate any Python expression, and what's interesting about eval is that I can use this to access other pieces of code. That's what makes it a little bit dangerous. So for example, I could actually call this function. So let's execute our code again, and let me try to call the demonstrate exec function, which is defined above. Now, I can do that, and it actually executes that function hello Alice, and obviously there's no return value from that, but that's why you want to be careful how you use eval, because if you use it incorrectly, you could have someone that's like calling other functions or modifying your code from this evaluation. Anyways, let's go to demonstrate safe eval. This is a safe way to use the evaluation function, and this actually involves defining what variables the user will have access to if they're using eval. So similar to how we have the global and local scope here, in this eval function, we're able to actually pass a local and global scope that will be used when we do an evaluation. So this time, what's going to happen is same thing. I'm going to ask for some expression, but I'm only going to define 3 variables, A, B, and C. And I'm going to pass those in the local scope. And this means that when we do the evaluation, it only has access to what's been defined here. So I'm not going to be able to access the other function. I'm not going to be able to access any other variables or code. And it limits what I'm able to mess with because I'm just defining what this evaluation should have access to. So let's run this here and you'll see how it works. So if I try to call, let's just copy this again, demonstrate exec this time, you'll see that it says it's undefined, right? And it's undefined because it's not defined in the scope that we pass to the eval function. So if we run this again, but we can use the variable A, B, and C because those are defined. So I can do something like A plus B plus C, and you see we get the result of the safe evaluation was 9. So that is how you do dynamic code execution using eval and exec. Again, be very, very careful with these functions, but they are cool to mess around with. Moving on, we are looking at function and variable annotations. Now, this is super useful when you're writing production-grade Python code, and you want to document the code while you write it. Now, these are features that don't actually enforce anything, so it doesn't enforce that something needs to be a string or an int or a boolean. It just indicates that it should be to give developers a better autocomplete and experience when they utilize your code. This can be good for yourself or for teams, but I want to show it to you because it is quite useful. So you can see here that when I define a variable, I have the option to actually annotate or define what type I want it to be. So I can do name, and then I can use the colon. When I do the colon, that indicates that I'm going to have an annotation here, and I can define this as something like a string. Now again, that doesn't enforce that this has to be a string. I could make this any type that I want, and I'm not going to get an error because Python is a dynamically typed language. But I do have the option to make the annotation, and now if I look at name, it indicates that this is going to be a literal or a string named Alice. I can do the same thing with age, student, and I can use my own classes. I don't have to use built-in Python objects for this. Now, what's more useful is when you do this with something like a function. So you can see here that I've defined the greet function. So I have greet, and I've annotated the different parameters. So in this case, person should be string, age should be an int, and I've defined that I want the return type to be a string. There's more advanced annotations, obviously, that you can use, but this is just a start, and this is how you indicate a return type. If you want to have none as the return type, then you can indicate none like that. Okay, now what we do inside of here is we write what's known as a doc string. Now a doc string is kind of what it describes. It's a document string, so it's defining what the function actually does, giving some documentation for it, and Python can actually automatically pick that up and use it in a meaningful way. So the first line of a doc string is typically a short description of what the function does, and then afterwards we can define various parameters and return types. Now look at how the parameters are defined. We have a colon, we have param, we have the name of the parameter corresponding with the annotation, and then we have a description of what the parameter should be. Same thing for the other parameter, and then we have the return. Now notice when I hover over greet here, because we've added that doc string and because we've added the annotations, we're able to actually see a description of how the function works. We have greets a person by name, we have the parameters person and age, and we have the return type. Now if I even just remove the M here, and I go back to this, you'll see that now that other parameter is not showing up because it's not correctly formatted, and Python or our autocomplete here in VS Code isn't able to pick that up. So if you want to write code that's well documented, then make sure you write it in this format. You can use triple quotation marks, you can do a multi-line string, and then you can write a doc string for your function, and of course you can have annotation for the different function parameters. If you want to look at the annotations, you're able to do that by calling it directly on the function itself, or you can look at all the annotations that are in the global scope. Moving on, the next feature I have for you is known as the Descriptor Protocol, but really what this means is overriding the repr and string dunder methods. Now, if you're not aware, when you work with an object in Python, they have some built-in functionality. For example, if I try to convert an integer into a string, so like string of 1, this just works, right? And it gives me the string of 1. This works on pretty much all your built-in Python objects, and the reason it works is because behind the scenes, the class that defines an integer actually implements a method called string. Now this underscore string method is what's called implicitly when you try to convert something into a string. Now that can be done directly when you're using the string function or when you're printing something out. So for example, when you try to print a list, the list class itself actually has a string method, and that string method is called in order to print out the list and give kind of a good representation of what it actually is. I know it's a little bit confusing if this is the first time that you're seeing it, but these dunder methods or double underscore methods, which is what they're referred to in Python, are kind of these hidden methods that are activated when you use particular syntax with an instance of an object. So in this case, I can create my own class. So I have class person. I have, of course, my initialization method, which is called implicitly when I create a new instance of person. And then I have two new dunder methods that I've defined. The first is repr or representation, and the second is string. Now these are a part of the descriptor protocol, which are things you should always add to all of your Python classes, and the reason for that is so that they can be used properly within the Python kind of ecosystem or language. So let's quickly go over the difference between repr and string because these are commonly kind of misconstrued. So I have repr is meant to provide an unambiguous string representation of the object. It's often used for debugging and should ideally return a string that could be used to recreate the object. So you can see that if I were to copy what's returned by repr here, this would really be the initialization line for my object, and it's useful when I'm debugging and trying to kind of look into the code. Whereas string is meant to provide a readable string representation, something that maybe a user will see or that you'd print out into the terminal. So whenever you're defining your objects, you should implement the repr and the string methods, and when you do that, that allows you to directly print out instances. So I could now print out person, and when I do that and run my code, you see that I get Alice, 30 years old. Whereas now if I call the repr method on this, which just returns a string, it doesn't print it out, so let me call repr on Python, you can see that we get this unambiguous version where I can now copy this and use it to create a new version of this instance. Now there's all kinds of other really useful double underscore methods that allow you to really hook into some advanced functionality within the Python language. I don't have enough time for them in this video, but I'll leave a video on screen that goes over them in case you want to check them out further. Now the next feature for me to cover is a decorator. Now this is a little bit more advanced, so if you want an entire video that's a bit longer and more detailed, I'll link that on screen, but for now I'll try to explain this pretty quickly. So a decorator is simply a function that modifies another function. A lot of times when you're writing code, there's an operation that you may want to perform multiple times, and you may actually want to do that for a function. So for example, every time you call function A, you want to maybe time how long it takes to run. Now, chances are you may want to use that timer later on for function B, C, D, etc. Or maybe you want to take the result from a function, maybe it's a string, and you want to strip some characters off of it, or you want to parse it in a particular way, and you want to use that multiple times. There's all kinds of reasons you may want to modify what's being returned or the way in which a function is being called. Now, in order to do that, you can use decorators that are built into Python that look something like this, or you can write your own custom decorator, which I'm going to show you right here. Now, keep in mind, what a decorator does is modify the function call and potentially what's being returned. So let's have a look at an example of my own custom decorator up here and kind of how this works. So really what a decorator function does is return another function. Now, this function is what will be called instead of the function that's being decorated. So you can see that I have my decorator, which is used with this at syntax. So I say at my decorator. When I do that, I'm saying, okay, I want to modify this function here with this decorator. So my decorator function itself, so like the actual decorator that I'm writing, what it does is it defines a function inside of it. This is the wrapper function, or what's actually going to be called instead of the say hello function. Now, this decorator function takes in the function that it needs to modify. Then the wrapper function inside of here will take in any number of positional and any number of keyword arguments. Really, all this means is it will take any arguments at all that you could possibly pass to a function so that this will work for any type of function. Then what I'm doing is I'm going to say, okay, print before the function execution. Then I'm going to call the original function that we're modifying, and I'm going to pass all of the arguments and keyword arguments that were passed to it originally. Then I'm going to print after the function execution, and I'm going to return the result that came from this function. I know it's still a little bit confusing, just bear with me. What I do from the decorator function itself is I return the wrapper, which is this new function that will be called instead, and then it essentially modifies the function that I've decorated. So let me just get rid of one of these so that this is a little bit more clear. Okay, so you can see that I have say hello, which is this function, and I'm passing Alice to it. Now let's just run it quickly and see what we get. And notice it says before the function execution, hello Alice, and then after the function execution. So really what ended up happening was this wrapper function got called, and because the wrapper function got called, we printed out this, we called the original function, we printed out this, and we returned the result, which we then could print here. Now, obviously, this didn't return anything, but we would have got that return type. So what happened when I called say hello Alice is since this was decorated, Python said, hey, we have this decorator here, so we need to actually get a new function to call instead. So it called my decorator function, and it passed this function as the function argument. Then what happened was we returned this wrapper function. So it returned that and it said, okay, we need to call the wrapper function instead. So we called the wrapper function and we passed as an argument Alice, which is just passed in here as star args. We then printed this. We called the original say hello function with whatever the argument was, which was Alice. And then we stored the result. We printed after the function execution, and we returned the result. So now I have a decorator that works for any function. Now, just to make this more clear, what I'm really doing when I add that decorator on top of say hello is the following. I'm saying say underscore hello is actually equal to, and this is my decorator with say hello. So this is effectively the exact same thing as adding that decorator syntax. And when I run this, notice we get the exact same code as before. So maybe that helps you visualize what's going on, but we're changing the function definition here. So rather than being the original function, it's actually whatever this wrapper function is that's returned from the decorator. And inside of the wrapper, you can modify the function however you want by doing something beforehand. You can maybe validate the different arguments. You could validate the return type. You can do anything you want inside of the decorator function that's applicable to, well, any function. So again, the shorthand is just to put the @ symbol and then the name of the function that you want to use as a decorator. You can use built-in decorators from Python, or you can write your own like I did here. How many of you have seen code that looks like this? You have this with that you probably don't know what it's doing. You have something like opening a file, which is pretty common. Maybe you save that as a variable, and then you write to the file. Now what this actually is a context manager, and I'm going to show you what this is doing behind the scenes so you can understand why it's useful to use and potentially how to create your own. Now this context manager, what it actually does is it handles the processing of a file, whether it's opening, reading, etc. Specifically, it will handle automatically closing the file for you, whether an error occurs or you are successfully able to perform your operation. So it's typically considered good practice to open a file in this way because the context manager, which is just what's handling all of this when you use with, automatically opens it for you and then closes it for you without you having to do anything too complicated. Now, if we didn't use this and instead we just did something like f is equal to open, we could potentially run into some issues when we try to operate on the file where the file could stay open and cause a memory leak. So if I didn't close the file, for example, like I forgot to close it or an error occurred before I could close it, then this would be problematic, and that's why we use the context manager. Now let me show you my own context manager that kind of mimics that open function so you can see how it works. So here I've said class file manager. What I've done is defined an initialization where we take in a file name and a mode and then store some internal state, which is the file itself. Again, very similar to that open function. Now, when we write our own context managers, we have to override an enter and an exit function. Now, these functions allow us to use that with syntax. When we have that first line where we say with, and in this case it would be file manager, what will happen is we'll automatically call this enter function. The enter function will perform some initial setup operations, and then clearly down here, the exit function will do the teardown operations when we exit the context manager. So inside of enter, we can open the file, right? So we open the file using the open function, and we just print out some information so we can see what's going on. Now we can also return this, and when we return this, that allows us to use that as syntax. So we can say, open as f. The reason we can do that is because we're returning some value, so that'll be stored in the as. Okay. Now we have the exit. This is the cleanup operation of what happens when we exit the context. What we take for exit is an exception type, an exception value, and an exception traceback. Now these values could be none, but they are possibly going to pop up. So inside of the context manager, if an error occurs, this exit function will still be called, which is one of the main advantages of using it. And if it's called when an exception occurs, then these values will store the appropriate kind of values, I guess, that were the cause of the exception. So inside of exit, well, I want to close the file. I want to clean it up and make sure this is good. So I'm going to print out that I'm closing the file. And then if there's an exception, I'm going to handle that here. So I'm going to say if some exception type, then let's print out what the exception is. Now I could handle this and maybe do some fancy operation. Otherwise, I'll just return true. And this will suppress the exceptions. So what that means is that if an exception occurred or it didn't occur, it doesn't matter. By returning true, we're not going to actually cause the program to crash. Whereas if I return false, then this is going to show the exceptions in the console and it will cause the program to crash, or we need to manually handle the exception outside of the context manager. Okay, let's look at how we can use this here. So you can see that we have with file manager, we pass the name of a file, we're going to open this in write mode, and then we say as file. Now we can write to the file, and then we have this line, file written successfully. Now this uses the context manager, which means as soon as this line is invoked, we're going to automatically call this enter function. This enter function is going to open the file for us, it's going to return that file and allow us to use it. Then as soon as we're done with the context, so as soon as we get to this line right here where my cursor is or where my mouse is, I'm not sure if you guys can see that, we're going to automatically call the exit function and clean up and close the file. Now, we can do the same thing with this here. So we say with file manager, we can open this in read mode, we can try to read the contents, and then we can print out what the content is. Now, if there's an exception within this block, it will be handled by the exit function automatically, and it will automatically close the file, and we can print that out. So maybe I'm going to say raise exception, and we'll just raise some exception here to see what happens, and let's run this and see what we get. Okay, so you can see it says opening file example.txt, file written successfully, closing. It says opening file example.txt, closing file, and then an exception occurred, hello. Okay, so there you go. Now, the reason that worked is, again, because the exception occurred. Since the exception occurred, we went directly into the exit block. We saw that we did have this exception, so we printed out what it was, but we suppressed the exception by returning true. So that is the advantage of using a context manager. You can control what happens when you are invoking the context and when you are exiting the context. And this is a useful way, again, just to have some more control on what's going on, especially if you're working with things like files, or you need to make sure things are opened or closed, or you have kind of a setup and tear down operation. Moving on to the next feature, I have iterators. Now, an iterator is something that can provide a sequence of values to us, and it's often used without actually knowing that it's being used, and a lot of times you might hear me actually saying something like an iterable object, and you might be wondering what that is, and this feature here is going to help break down how that works. So I've written my own custom iterator here, but we're not going to look at that quite yet. For now, I want to look at kind of a default or vanilla Python example so you can see what an iterator actually is. So what I can do here is grab this range function. So I'm going to say r is equal to range and then pass 10. Now, range itself is not an iterator, but it can be converted into an iterator when it's used in something like a for loop. So what I can do is say itr is equal to iter and then pass r here. And what this does is return an iterator. Now, an iterator is simply a Python class that contains two dunder methods. The dunder methods are next, which gives you the next value in a sequence, and underscore iter underscore. Now, the iter function is what's called when you call this iter, which is what I'm doing right here, and this is going to set up the iterator and initialize all of the values. The next function is what gives you the next value in the sequence, and these are actually the functions that a for loop will use implicitly. So let me show you kind of step by step here. What I'm going to do is I'm going to print next on itr, and we're going to do this 2 times. Okay, so let's go here and execute the code, and notice that we get 0 and 1. Now, that's coming directly from the range that we've set up, and if we wanted to, we could modify this to maybe start at 10, start at 2, stop at 10, and now notice we're getting 2 and 3. Okay, so the next function gives you the next value from the iterator, and you can keep using this next function until what's known as a stop iteration exception is raised. So for example, if I go 2 and 3, and we stop at that value but don't include it, when I do this, notice I get 2, and then I get a stop iteration exception. Okay, so that's kind of how the next function works. You can call this on an iterator or something that has underscore next defined, which are a lot of things in Python that you probably don't know about. And eventually, when there's no more values to get, it returns stop iteration or raises that exception. Now, behind the scenes, when you use a for loop, that's exactly what Python is doing. So if I do something like for I in range, and then maybe we go up to 3 here, and I print out I, what's actually happening behind the scenes is we're calling the iter function on range. That iter function returns an iterator. That iterator has that next function, so the underscore next, and that next function is used as we cycle through all of the values in the range, and as soon as we have stop iteration, the for loop stops executing, and it just moves on to the next line. So that's how an iterator actually works, and that's how Python utilizes it, by utilizing that next function and that iter function to set it up. So hopefully that makes a little bit of sense, but what I did before when I called those next functions for you is I was manually making the for loop. So in fact, if we wanted to manually make the for loop with the while loop, we could just say while true, and we could say value is equal to next from itr. We're going to put this in a try block though. Okay, we're going to say except stop iteration, and we're just going to break, and then we're just going to print the value here. Okay, so now let's go 2 to 10. We have our while loop. We're going to get the next value, print the value, and then as soon as we have a stop iteration, we'll break. And when I run this, you see that we get all the values, and we've just built our own for loop essentially that uses this iterator. There you go. Okay, so that's how that works. Now let me show you my own custom iterator. We'll go through it kind of quickly because I explained a lot of the main features. So I have an iterator here called myRange. This takes in initialization, or has an initialization where we can take a current and an end. Okay, then we have iter. What iter does is just return an object that has this next method defined on it. In this case, we're returning ourself, but we could return an instance of another class. We just need to return something that has this underscore next method, because that's what will be used to grab the next values from the iterator. Okay, now instead of the next method, I say if self.current is less than self.end, then I'm going to say the value is equal to this, increment the value, return the value, otherwise raise stop iteration. And now I can actually use my own iterator in the for loop. So I can say for number in my range, and then we can print out the values. So if I do this, you see that we get 1, 2, 3, 4, because exactly how the for loop works, it calls this next function until it gets stop iteration, and then it stops. And when it first looks at my range here, it calls this iter function, grabs this itself, which has next on it, and there you go. Okay, that is an iterator. Hopefully that makes sense. Moving on, we're talking about generators. Now, generators are really just a more modern version of the iterator, and they work by using a yield keyword inside of a Python function. Now, using this yield keyword actually allows you to pause the execution of this function and only execute a little bit of code, return a value, and then pause and wait until you're asked for the next value to generate. I'm going to show you an example here, but generators are typically used when you want space-efficient kind of execution or calculations to be done. So for example, let's say we want to count up to 10 million. Well, if I want to count to 10 million, I don't actually need to first generate a list of 1 to 10 million. Now I could, right? I could generate all of the different values, but that means I'm going to be storing 10 million values inside of a list. And since I'm only using the values one at a time, I don't need access to all of them at the exact same time, there's not really any point in me generating all of them and putting them in this sequence and then maybe looping over them and using them later on. So rather than doing that, we can use a generator. Now the generator can give us each value one by one and only store one value at a time when we need to use it. Now this is kind of a silly example because we're just counting, but imagine there's an advanced calculation and maybe we need to do that 1,000,000 times. Well, again, we don't need to first do the 1,000,000-time calculation, store all 1,000,000 results, and then use them. We can just do the calculation on the specific value that we need at that time, so we only store one value in memory at a time. Anyways, let me show you how the generator works, and I'll actually link a video on screen that goes more in detail in case you're curious about it. Okay, so I have count up to max. Now this is a generator function, as you can see here, and the reason why it's a generator is because we have yield. As soon as you use yield, it becomes a generator. Now I have current equal to 1, I have while current is less than the maximum value, and then I yield the current value. Now this yielded value is grabbed by using the next function. Now this looks familiar because it's the exact same way that we used in iterator. So I can print the next on counter, and you're going to see as long as I comment out the for loop here and I run the code that we simply get the value 1. Now I could do next again. I just want to show you that we're getting the next value, and we get the next value, which is 2. Okay, so we are yielding a value. And as soon as we yield a value, we actually pause the execution of this function and we wait at this yield line until the next value is requested. So we go next counter, okay, we execute up to here, then we wait. We see next counter again, we then execute the current plus equals 1, current is now equal to 2, we go back into the while loop, we yield the next current value, and then we pause and we wait. Okay, that's really how the generator is working, and by using this yield keyword, this next function is automatically created for us, or it's automatically kind of implemented, allowing us to use it to grab that next value. That's it. That's really all you need to know about how the generator works. Now what we can do is we can use it in something like a for loop. Okay, so let me get rid of this comment and run it, and you can see now that this will just count all the way up to 10 million, and we don't need to actually generate all 10 million values in order to do that. We just get one by one. Obviously, this is not the most useful thing in the world to do, but a lot of times you need to do some more advanced calculations, and again, rather than doing all of them, storing them in memory, you create a generator that can just do it one by one, and then you just yield the values as you need them, so you only ever store one value in memory. Okay. So that is a generator. Again, I'm going to put video on screen that goes more in detail. Now let's move on to the next feature. Moving on to the next feature, I have the Itertools library. Now this is more just to encourage you to check it out because it is super cool, but the Itertools library is really what allows you to take advantage of more advanced iterators in Python. Now I just have 3 simple examples here to show you, but there are tons of others that you can check out. Again, please look at this after the video. So you can see that what I can do with the Itertools library is create things like infinite iterators, where I actually can infinitely count up in a sequence similar to what I could do actually with the generator that you saw before. So I have infinite counters starting at 10, increasing by 2, and now I can just use this iterator as many times as I want infinitely without ever having to stop it or tear it down. Next, I have something like cycling through a finite sequence. So I have Itertools.cycle, and then I have next, 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 and I can just keep going and cycle through this sequence. Next, I have things like ability to create all of the combinations or permutations of a particular iterable. So in this case, I have ABC, and I want to create all of the combinations of 2. So AB, AC, BC, etc., and I can list all of those different combinations out. This will actually give me an iterator that contains them, so rather than returning all of the values at once, it gives them to me one by one so I can process them as I need them. But if I want to just print them out, I can print out a list of the combinations. There are a million other things you can do with the Itertools library, so please look at it if you do need to do anything that is more advanced with iterators. And now let's move on to the last feature. So now we're moving on to the final feature, which is asynchronous programming. Now this utilizes the async.io library, which is a relatively new library, at least in one of the newer versions of Python. And this is an easier way to handle multiple concurrent tasks rather than using something like threading. Now I'm not going to do asynchronous programming justice in this video by explaining it in just a few minutes. So I am going to link a video on screen right now that you can check out that breaks down everything you need to know about asynchronous programming in Python. Shows you all of the syntax, walks you through the various features, but I will quickly explain an example where you would want to use async.io so you can see the benefit of it. Now I have some code here just in case you want to look at like some of the main features. I'm not really going to explain it, but the point is with async.io, we might have the following situation. Let's say we're writing some code and we want to do something like send a network request. So we want to go to a website and maybe grab some data. We want to post some data there, something that isn't really dependent on our computer or our code. We're asking some other system for something, right? Maybe it's the operating system. Maybe it's the user to type in some input. We're just waiting on something that we don't really have control over. We don't know how long exactly it's going to take. Now, if that's the case, while we're waiting for that operation to complete, we potentially want to complete something else. Maybe we want to process some other data, or we want to allow the user to be interacting with our program while we're waiting for this network request to finish, or this email to send, or whatever's happening. In order to actually do that, we need to use asynchronous programming. If we don't use asynchronous programming, what would happen is maybe we want to send a network request. Well, now we need to wait for the network request to send before we can do anything else. So even if that's not a blocking operation and we can continue in our code or our program or our game or whatever, we just have to sit there and wait, and we can't do anything else until we get the result back. Asynchronous programming allows us to handle the timing of different events. We can respond to things when data comes in. We can set up multiple different tasks and schedule those to run at the exact same time. And it allows us to more efficiently write code. So that's the advantage. Definitely need to learn it. And again, I'm going to link that video so that you guys can check it out and really get a full taste of what async.io is. With that said, guys, I'm going to wrap up the video here. I hope you found this helpful. If you did, leave a like, subscribe, and I will see you in the next one.